Designing in 3D with a 2D mouse feels wrong, right? If you have ever worked with 3D modeling softwares like Fusion 360 or Blender, you know how frustrating it can be to rotate, orbit, or zoom precisely with a mouse or a trackpad. It's clunky and intuitive, and you're constantly switching between tools or fighting the viewport. You're designing in 3D, but your input device is stuck in 2D. That's the gap. That's what we are here to fix.
Now, then let us see a novice at work, struggling with rotating and orbiting the model in the Fusion software.
Introducing you Fusion Orbiting Mouse, a device that speaks the language of 3D, just like your hands do, powered by Arduino Nano 33 BLE Sense. It uses real-time motion tracking to orbit and rotate your model just by moving your hand. No clicking, no dragging, no limits.
And here we have the same novice now using the Fusion orbiting mouse and being able to freely control his virtual objects in real life. The movement of objects are very precise and allow the user to move the object to the desired location and rotations.
At the heart of this device is the Arduino Nano 33BLE Sense Rev 2, a microcontroller that's small, powerful, and packed with sensors. It's got a built-in 9-axis IMU, which means it can detect rotation, orientation, and acceleration in 3D space. That's exactly what I need to translate hand motions into 3D model controls. On top of that, it has a Bluetooth low energy built right in, so I can wirelessly send motion data directly in my computer. No dongle, no external modules. It also runs on 3.3 volts and is compact enough to fit into any custom shell or wearable I might want to make later. And if I want to expand in future, it's got a mic, temperature sensor, and even gesture recognition support. So in short, it's not just a microcontroller, it's the brain of the Fusion orbiting mouse.
So here we have the code for the Arduino side, the hardware side. For now, looking at the code, we are doing nothing but basically importing the necessary libraries, initializing the necessary variables, and initializing the get characteristics over here. The characteristics and the services are the main life of the hardware, which makes sure that the BLE transmits the values in short periods. Finally, adding some extra variables for the security purpose. And going to the setup section, basically we are initializing the hardware to accept the values. And finally, in the loop, all the values are read if no errors are thrown, and the values are sent over to the receiver.
To connect the Arduino Nano BLE Sense with the Fusion 360, I built a custom Fusion add-on that acts as a bridge between the physical motion and the 3D modeling environment. The Arduino sends live sensor data from the onboard IMU, which includes acceleration, gyroscope readings via Bluetooth Low Energy, that is BLE, to the desktop. But the raw data can be very noisy and inconsistent. So inside the add-in, I implemented sensor fusion algorithms like Kalman filter to smooth out the data and extract clean, accurate values. From the filter data, I calculated the pitch, roll, and yaw of the device, basically how your hand is oriented in the 3D space. Then comes the maths. Using these angles, I compute the transformation matrices needed to control Fusion's viewport camera. So as you rotate your hand, the 3D model orbits in real time, exactly how you expect it to do it.
Let's have a demonstration for the client side. Here, first we have the BLE file which deals regarding the Bluetooth Low Energy. It receives the notification from the from the sensors and applies the sensor fusion file from the camera file. In the camera file, first we have imported all the necessary modules and calculated the pitch, yaw, and roll, which are necessary for the further calculations. Now, to update the camera, we calculate the eye position using mathematics. Then we calculate the radius, and finally we update the camera. The updation of the camera incurs the updation of the viewport in the Fusion 360 workspace. Now the workspace reflects these changes using the entry.py file. The entry.py file is the main file which calls all the underlying structures and modules. The entry.py file is the header file, which encompasses all the previous shown files over here.
For the physical hardware, I am currently using a 3-axis gyro gimbal as the main body of the Fusion orbiting mouse. At the center of the gimbal, I have mounted the Arduino Nano 33 BLE Sense Rev 2 strategically to ensure accurate motion and tracking without interference. On the back, there is a compact LiPo battery powering the entire system, and I have also added a small display showing the battery percentage in real time. This setup gives me a fully handheld wireless 3D controller that responds to your hand natural motion. Of course, this is just an initial prototype. The goal here is to validate the concept and test the responsiveness. In future versions, I'll be working on a more ergonomic design, possibly with 3D printed enclosures, touch controls, or even haptic feedback for immersive interaction.
$56.